Hi friends, once again welcome back in our educational channel, that is Precise Electronics. Friends, in today's video lecture we are going to study Kirchhoff's law. Kirchhoffs, it is the name of the scientist, and there are two laws, and we are going to study that two laws. The first law, that is known as Kirchhoff's current law. So friend, what is Kirchhoff's current law? Kirchhoff's current law is also known as Kirchhoff's junction law, and actually it is Kirchhoff's first law. This law defines the way that electric current is distributed when it crosses the junction, when it crosses through a junction. So what is junction? Junction is a point at which three or more than three conductors meet. Junctions. Suppose this is one conductor, this is another conductor, this is one more conductor, this is one more conductor. So all these conductors meet at the point, at the node, and this node is known as junction. And this law gives how the current is distributed at the junction. And this law is known as Kirchhoff's first law, and that is Kirchhoff's current law. It is also known as Kirchhoff's junction law. What is the statement of this law? This law, that is Kirchhoff's current law, states that the algebraic sum of current into any junction is 0. Suppose this is conductor 1, this is conductor 2, this is conductor 3, 4, 5, etc. Suppose current flowing through conductor 1, that is I1, through second, that is I2, then I3, I4, I5, etc. At the junction, this current flowing toward the junction, or at the junction, the current is 0. So at the junction there is no current. The incoming current is always equals to outgoing current. So what is the explanation of Kirchhoff's current law? Basically, what is current? Current is nothing but a flow of electrons through conductor. When the electron moves or travels through conductor, the current conduction takes place. So it can build up at a junction, meaning that current is conserved. What is current? Current is a flow of electrons through a conductor. It cannot build at a junction. So at a junction there is no current. It cannot build at a junction. What comes in must comes out. Means the current flowing toward the junction, what comes in is equal to comes out. That is current flowing away from the junction. If we consider all the current, suppose there are 5 conductors. I1, current flowing through first conductor, that is I1, then next I2, I3, I4 respectively. If I1, I2, I3 are the current flowing toward the junction, and I4, I5, etc. are the current flowing away from the junction, if we consider all the currents enters in the junction, suppose this is the junction, and these are the current moving toward the junction. So current moving toward the junction is considered as a positive current. So obviously current that is moving from the junction, moving away from the junction or leaving the junction is considered as negative current. What is positive current? Current moving toward the junctions are known as a positive current, while the current moving away from the junctions are considered as negative currents. Now if we add all these positive and negative currents, that means current flowing toward the junctions and current flowing away from the junctions, obviously we will get result of 0. So I1, I2, I3, suppose I1, I2, I3 are the current flowing toward the junctions, and I4, I5 are the current flowing away from the junctions, then I1 plus I2 plus I3 minus I4 minus I5 must be equal to 0. That is Kirchhoff's current law. So Kirchhoff's current law can be restated as, the sum of current flowing toward the junction, sum of current flow into a junction is equals to sum of current out of junctions. What is the Kirchhoff's first law? The sum of current into junction. Suppose this is the junction. The sum of current flowing toward the junction equals the sum of current flowing away from the junctions. That means the sum of current flowing toward the junction is always equal to sum of the current flowing away from the junctions. Now one diagram will be going to display on your screen. I1. that is current flowing toward the junction. There is node that is indicated by the green mark. The green point is there. So I1 is the current flowing towards the junction. Obviously it is positive. I2 is the current flowing toward the junction. It is also positive. I3 is going away from the junction. It is moving away from the junction. So obviously I3 has negative sign. I4 is also current flowing toward the junction. So obviously I4 is positive. And I5 is a current flowing away from the junction. So in this diagram, in this figure, I1, I2 and I4 are the current flowing toward the junctions. I1, I2 and I4 are the current flowing toward the junctions, while I3 and I5 are the current flowing away from the junctions. So sum of the current at node is equal to 0, because at node, at junction, the current will be 0. So sum of the current entering the node will be 0. So the current entering towards the nodes are I1 plus I2 minus I3. Actually it is a plus sum, but I3 is a negative because it is a current moving from the junction. So I1 plus I2 plus minus I3, that is I1 plus I2 minus I3 plus I4 and minus I5. So what is our equation? I1 plus I2 minus I3 plus I4 minus I5 is equal to 0. Similarly, the sum of current leaving the junction, leaving the node or leaving the junction is also 0. So it is now minus I1 because current moving away from the junctions. So it is minus I1 minus I2 plus I3 minus I4 plus I5. Because in this case, what is the reference? The reference is the current moving from the junction. So minus I1 minus I2 plus I3 minus I4 plus I5 is equal to 0. The current flowing toward the junction, the sum of the current flowing towards the junction is equal to sum of the current flowing away from the junction. That is the Kirchhoff's current law. So obviously I1 plus I2 plus I4 is equal to I3 plus I5. That is Kirchhoff's current law. It is the equation of Kirchhoff's current law. I1, I2 and I4 are the current flowing toward the junction. So sum of this current I1 plus I2 plus I3, I1 plus I2 plus I4 is equal to current flowing away from the junctions, that is I3 plus I5. That is a Kirchhoff's current law, which is known as Kirchhoff's first law. Now friends, we are moving toward the second law. What is second law? Second law is known as Kirchhoff's voltage law. Kirchhoff's voltage. This law describes the distribution of electrical voltage within a loop or a closed circuit, a closed conducting path. What is the use of this law? This law is used to describe the distribution, how the voltage is distributed in a closed loop circuit. In a closed loop circuit, how the potential, how the voltage is described. Here, how the potential difference is described. This law states that, what is the statement of this law? Second law, Kirchhoff's second law. This law states that the algebraic sum of the voltage, or it is a potential difference in any loop, must be 0. The algebraic sum of potential drop, or it is a voltage, the algebraic sum of voltage or potential drop in any loop, in a closed loop, must be equals to 0, is always 0. This law is Kirchhoff's second law, and it can be alternatively said that the net voltage gain, that means a net voltage applied, provided to that circuit, that is a net voltage gain, and a net voltage drop, that means a component used in circuit, the potential drop across the component, that is the net voltage drop along a closed loop, are equal. Whatever may be the potential applied is always equal to the potential drop or potential developed across the components used in this circuit. Now for the explanation of this law, a diagram is used, a circuit diagram is used, and that circuit diagram is displayed on your screen. From this diagram, it is clear that the loop is closed. V1, V2 and V3 are the three batteries or power supplies are connected in these circuits, and three another components, that is a R1, R2 and R3. The three resistors are used in these circuits. So obviously, if we consider in a closed loop, conventionally, if we consider the voltage gain along the loops are positive. Voltage gain along the loops are positive means the applied potentials are considered as a positive. So obviously in this case V1, V2 and V3 are the applied potentials, are the batteries connected in this circuit. So they provide the potential, they provide the voltage to the circuit, and hence these potentials are considered as positive. So V1 and V2, V1, V2 and V3 are the positive, are considered as positive, and the voltage drop along the loops should be considered as negative. So obviously the three resistors are used, R1, R2 and R3, and hence the potential drop across R1 is VR1, across R2 VR2, and across R3 is VR3. So VR1, VR2 and VR3 are the potential drops across or potential developed across that components, that is resistors, and these potentials are considered as negative. So by using this law, the applied potential, the summation of this potential, that is applied, the gain of the potential and the potential drops must be 0, is equal to 0. So voltage source V1, V2, V3 provide the voltage. The resistors, the drop across resistors are VR1, VR2, VR3, which are considered as negative. So the voltage along the closed loops are, voltage along the closed loops are V1 plus V2 plus V3. Why it is positive? Because they provide the potential, they provide the gain. So V1 plus V2 plus V3 are considered as positive, while VR1, VR2 and VR3 are the potential developed or potential drops across the resistors. So obviously they are considered as negative. Therefore V1 plus V2 plus V3 minus VR1 minus VR2 and minus VR3. These are the potentials in this loop. Applied potential and potential developed. So now as per the Kirchhoff's voltage law, the Kirchhoff's second law, the summation of all these voltages are 0. Results will be 0. So V1 plus V2 plus V3 plus minus VR1 plus minus VR2 plus minus VR3 is equal to 0. That means V1 plus V2 plus V3 minus VR1 minus VR2 and minus VR3 is equal to 0. Or V1 plus V2 plus V3 is equal to VR1 plus VR2 plus VR3. So according to Kirchhoff's voltage law, the summation of voltage, that is V1 plus V2 plus V3 minus VR1 minus VR2 minus VR3 is equal to 0. So summation of this voltage is 0, or the gain, the voltage gain, that is V1 plus V2 plus V3 is equal to the potential drops, that is VR1 plus VR2 plus VR3. So friend, that is Kirchhoff's voltage law, that is Kirchhoff's second law. So friends, in this video lectures we had studied Kirchhoff's current law, that is the first law, and the Kirchhoff's voltage law, that is second law. So friends, thanks for watching this video lecture. Bye, take care, see you again in our next lecture. Bye, thanks for watching this video, take care.